Hello and welcome to my tutorial on how to create L systems within Unity. First things first, before we get into the code inside in Unity and all that, I thought I would explain what L systems are. Basically, they're a system on how to generate life, which we can use to procedure generate trees and whatnot within the gaming industry. They're relatively simple. First of all, what you want to do is you want to define an axiom. So we have our axiom, and in this case, let's call it f plus f plus f plus f. Relatively simple. So this would just be a string within Unity. Then we have to give it a rewriting rule. So for example, whenever there's an f, we're going to replace it with f plus f minus f minus double f plus f plus f minus f. So now, if we did one iteration, we would then look through our initial axiom, which is f plus f plus f. So for every f, so it would become f plus f minus f minus f, f plus f plus f minus f, plus the same string 4 times over. So that's after our first iteration, and if we did it again, for each f we found, we would then replace this string. And then by defining an angle such as 90 degrees, it would make a maze or something like that. So that is the basics of L systems, and I will discuss it more throughout the video. So I'm going to speed this up, that's why it's so fast, but we're going to create some new folders first of all. We're going to call them scripts, prefabs, and UI assets. This is where obviously we're going to store all the things we need for our scripts, UI assets, so on and so forth. Next, we're going to create a script called transform info. Open it up in Visual Studio and get rid of these start and update functions, and we're going to create a new vector-free called position and a continuing forward rotation. And that's all. Save the file, go back into Unity. Now we're back in Unity, we're going to create a new C# file. This time we're going to call it L systems generation. Open up in Visual Studio, keeping the start and update function because we need them up the top. We're going to add in using Unity engine.ui. We're adding using Unity system or using system.text, which will allow us for string access. Now we're going to create some private variables, 3 floats, one called angle, one called length, one called width. These will all define how big our tree is, and a private integer called iterations, which is responsible for how many cycles through this process we will do of generating trees. Create a private string called axiom. This is what I explained earlier. And another private string called current string. And we're going to set that to empty, so it's got no information, because we will define current string as axiom in a minute. Next, we're going to create a serialized private dictionary. Serialized field means we can see a private variable within the inspector and edit it. So we're going to set its key as a char and its value is string, and we're going to call that rules. Next, we're going to do a private stack, and we're going to use its information for the transform info script, and we're going to call that stack transform stack. Now we're just going to make some more private game objects, but within a serialized field then, so we can add objects from the hierarchy into the inspector. We're going to have tree parent, which is what we use to group it all together. We're going to have our branch, which is what makes up the tree. We're going to create a game object called tree and equal that to no, and we're going to have a private game object called tree segment, which will be used to build the trees. Now within your start function, you want to define a new transform stack, and we're going to make a new dictionary called rules, and we'll leave it empty for the moment, so we're going to come back to it. Next, you're going to do a transform.rotate, and we're going to do vector3.right times minus 90. This will basically move it towards you. Next, we're going to set current string to equal the axiom. This will let the for each loop we're going to create know where to look within the dictionary. We're going to define call our generate function from the start. It will give you an error, but that's because it's not defined yet. Next, we're going to define our generate function, so it's going to be a private void, so it's not returning any values. Next, we want to destroy our game object tree in case we spawn some already. And then we're going to say tree, our game object we just destroyed, and we then instantiate a tree parent, which we will then use to even out our hierarchy. Next, we're going to make a new string builder function. We're going to call it SB, and we're going to assign that new string builder. So this will allow us to access the string builder function more easily. Next, we're just going to define out a line renderer. So call line renderer, call that line renderer with a capital L, and equal that to get component.line renderer. This will make it easier as well in the future. Now we're going to make a for loop, and we're going to say for integer I equals 0, when I is less than iterations, add 1 to I. So this will let our loop know how many iterations we want to go on for and stop it from being an infinite loop. Next, call a for each loop. And we're going to say character C in current string. So our current string, if you remember, is our axiom. We're going to append this to our rules with its current key or contains key C. The question mark is a if statement. So we're saying if rules C. So whatever our C is, our defined axiom, and the colon means is inheriting from this rules. And we're going to convert that all to a string so it can be put back in the dictionary. I'm going to say current string. I'll set our current string to what we've just defined out in that for each statement, and we're going to make a new string builder function for the next iteration. Now we're going to make another for each loop, same as above, for character C in current string, but this time we're going to use a switch statement to see what our values are. Because we're going to have, for example, f, x, plus, minus braces. So we're going to say for case f, vector 3 initial position is equal to our transform dot position. So the transform component, and then the position component of that transform. Next, we're going to do transform dot translate so we can move the tree or the branches of the trees. That's going to be a vector 3 dot forward, so in a forward direction times the length of the branch. Next, we're going to use our previously defined game object called tree segment. I'm going to instantiate a branch. So by instantiating the branch now becomes a tree segment, and now we can use a line renderer. So tree segment get its component of line renderer. So we're going to set its position. So we're going to need an index. That's just an integer. So its first index is 0. We're going to set that to our initial position, which we defined above. Do the same again, but change its index to 1 and its position to a transform dot position. So this lets it know to move up to its last position or the next position and start again. Next, we're going to do its start width and end width. So just do the same, get the line renderer component, but do dot start width and equal that to width, and then copy the line, change start width to end width, and equal that to width again. Finally, call tree segment, and you want to call transform dot get parent or set parent, sorry, and equal that to the tree we instantiated at the top of the generate function. After our F case, we got our X case, where this is we're just going to say break because we don't want it to do anything when it reaches an X. Next, we got the plus sign. This means to rotate a branch in a certain direction, and that is our defined angle, and that's in a positive direction. Next, we got the negative case, or the hyphen. This is exactly the same as the plus case, but we want to rotate it in a negative direction. So for our negative angle, we'll just put a minus sign for it. Then we got our open square brace. This just means to push into the stack of our class new transform info. So position will then become transform dot position. So this position will become transform dot position, and the rotation will become transform dot rotation. Finally, we got our closing square brace, where we're going to define a new transform info as ti, and then pop this from the stack. So we're going to remove it from transform dot stack. So our transform dot position, which we would have defined here, then becomes this transform info dot position and its rotation. Then we have our default case, so you need to be using system here. So you need to include that, and then we're going to use invalid operation exception. This allows us to say if none of these cases come up, throw this error. Finally, outside of the for loop or the for each loop, you want to divide your length by 2 and your width by 2. Now we just got to assign numbers to the actual variables. So angle 30, length 1, width 0.1, iterations 3. We put the rules into the dictionary. Now we need to create some empty prefab, so a tree parent, drag into your prefab folder. The branch, assign a line renderer to it, make that a prefab, and then a tree, make that from prefab. Make sure to delete them all from your hierarchy. Now on the tree prefab, if we assign the tree parent and the branch to their respective components, then we can make it a tree. and as you saw, it generates the tree. This is just a short clip on how to make a UI. All this, so I'm going to talk over this, but this is just how to make the UI, and once it's done, I'll come back and show you all the code that goes along with it. Once the UI is all finished up, this is the updated code. So if you look through this, we've got all our serialized fields. These are all input fields, buttons, and FLVs, and a slider. So name them accordingly, like I have, and this will allow you to assign them from the inspector. Here we've got our FLV value. This will be used because we're going to set this, our camera's FLV, to the field of view there, which is 60. Then we've got this section of code controls us moving up, down, left, right. This add value is called every time we click generate, so this adds our value and actually allows us to create the tree. Next we have our on enable function. This allows us to add listeners to our buttons. So generate button dot on click dot add listener. Then we put the function name called generate, so when it's clicked it knows to execute this function. Next we have our add values. So by using parse we can take the string value from the input field and convert this to a float and integers and so on and so forth. Next we have our reset values, so the empty strings just resets our input values to nothing. We've got to set our axiom, the current strings, as the iterations will go wrong, and reset all our angles, variables and all that, so we can reuse them. Next we got add to dictionary, so works the same. We just get our value from the input as text, a string, we can convert that, and as you'll see from adding to the rules, you just got rules.add, but here we use it as a string array, so this way it thinks it's a character, not just a string. Then we have our change axiom, so this works the same way. We're calling this from a button. We've got the reset axiom, we just set this to null, and then you got your on GUI, so we got minimum and max. We set this to this slider value through in the inspector, and this allows us to change our field of view. So with that all assigned, your inspector should like the one on the right. So now if we assign our axiom to x, our key value to x, and our value, the ones I just input, we can add all this to a dictionary. So our angle to 30, length to 1, width to 0.1, iteration to 3, and there you go. You generate a tree. You can move around using WASD. And if we click generate again, this will be 6 iterations. We can zoom out with the FLV slider. And there you go. Thank you for watching. Hope you enjoyed. See you soon.